All right, so we're now going to do some multiple representations, taking what we know and using that to match with other ways to represent our relations and functions. So here we're given a graph and we're asked which table could be a view of the function represented by the graph. Sorry, I again needed to be able to write. So I notice that we are going through 0, 0. So that's a point on our first, second, and third table. So that gives us an indication. All right, at least I have that point. So when I look at table 1, I have a point at 1, 3. Well, if I go to 1, 3, there is no point here, so table 1 is out. It's not going to represent the graph. All right, so if I go to the second one, we have a 1, -3. So that is a point, 1, 1, 2, 3, or down 1, 2, 3. So 1, -3 is a point. If I come over here, it has -1, 1. So if I go -1, 1, there's not a point. So the second or the third table doesn't work. And so I'm just going to double check with the second table that if I go to 2, and we're down at -6. So here's 4, -5, -6. And so far, or not even so far, it's going to continue working. So our middle table represents our graph. So again, I'm just taking what I know from the graph and the fact that each of these in the table is a point, and I've just got to make sure that that point is on the graph, x, y. It's as simple as that. I could also take the graph and finish a table if it was a partial table and I was needing to finish finding some values. I can just go to either the x or the y, whatever I'm given, and use the graph to fill in the table. Both of those can be done, or both ways can be done. All right, so here, example 6, a train leaves the station at time x = 0, traveling at a constant speed. That's important. That tells us that we're not, we're forever increasing, right? Constant, or our distance is forever increasing, I should say, because that's what our y value is. Traveling at a constant speed, the train travels at 332 kilometers in 2.9 hours. Round to the nearest 10 kilometers in the nearest whole hour. So 10 kilometers would mean, I lost my, hold on, sorry, I had lost my writing pen. So the train travels at 332, but we need it to the nearest 10 kilometers. 2 doesn't change the 3, so our nearest 10 kilometers is 330 kilometers in the nearest whole hour. So 2.99 will shove the 2 to a 3, so we have 3 hours. Round to the nearest 10, we already did that. Then represent the distance y the train travels in x hours using a table, an equation, and a graph. So I know that after 3 hours, I've traveled 330, which would give me the point 3, 330. Now, to find for 4, I actually got to figure out how much I traveled each hour. And so to do that, I'm going to do my y divided by my x. Oops, I started to write x instead of 3. So 330 divided by 3 is 110. And so I'm going to either think of this as 4 times 110, or add 110 to our 330, which would give us 440. So we're at 4, 440. And then 5 would be 550. So 5, 550. And again, either I'm taking 110 times 5, or I've added another 110 to my 440. So there's my table. To put that into an equation, y will equal, we changed by 110 each hour, so 110x. That is our equation. All right, for my graph, my y value is going to be distance. My x value is time. And we're going to do 1, 2, 3, 4, 5. And so then this would be 100. I'm going to count by 110s. Just because then everything fits. 30, 440, 550, 660. All right. So 0, 0, right? If we've not gone anywhere, then our first point is 0, 0. 1. All right, based off of our table, we would have 3, and then 330, 4, 440, and 5, 550. Now, I added these others because I know that for each hour, we just did 110. So for the first hour, we would have traveled 110 miles, or kilometers. For the second hour, we would have gotten 220. Now, we're going to draw a line through these. The reason we're drawing a line, this is what we call a continuous, because between each of those hours, I could find at the half hour and see how far we traveled, or after 15 minutes, how far did we travel. And so we have points in between the dots that we found. So that's continuous. So there's also what we call a discrete graph, and a discrete graph is when you only have certain x values, like you only have, you can only sell a certain number of cookies. You can't sell a half cookie. You can only sell it on the whole, not the half. And so there are only certain values for x, not all values of x. And so that's how we know whether it's discrete or continuous, and this one's continuous. So, but this is how I took a real world situation and now turned it into different ways of representing the information. And double checking, yep, that is it for this section. Until next time, 8th graders.